So welcome everyone again to the DS Incubator. This is the last meetup of the series that is covering the book, What They Forgot to Teach You About R. This is a meetup about the third section of the book, which is called All is Failed. All is Failed. And I'm going to be focusing on debugging R code with specific focus on working with like long-running processes. And this is motivated by some work that I'm doing right now with the PassTags team, when sometimes I need to debug some code, and before I even get to that code, there is very long processes that I need to run. And I've learned a few things, a few tricks that I would like to try capture in this talk as well. And this is also motivated by a conversation with Linda, who has similar challenges in some work that she's doing. So it's a pretty ambitious meetup. My idea was to walk you through a real debugging session that I had yesterday and kind of show you the gist of it. What we are going to be covering is, trying to locate where the problem in some code is with the function traceback. Try to reduce the problem by, for example, reducing the size of the data through an idea that is called binary search, to try to reproduce the bug as simply as possible. And if we want to share with someone else, use the reprex package. I'm not going to be showing how to do it because there is a whole meetup dedicated to that, a whole series actually dedicated to that. But at least, to mention the package in case you want to be kind of curious and explore it by yourself. Then we're going to be covering some fairly cool tricks that allow you to enter the computing environment of a function, for example, or of a for loop with functions such as browser and debug ones as well. Trying to get feedback from the inside of the function that is having some problems with functions such as message. Maybe navigate a little bit inside the debugger mode of RStudio with either the keyboard or the function debug once itself, which is particularly useful when we work with pipes. And finally, we're going to be talking about the idea of debugging when in processes that go through loops many times. So how do you ask the code to stop exactly at the place where the iteration has a problem? So there will be thousands of iterations that are just fine and one that is problematic. So you want to stop the code right there. And then more generally, I would love to have some time to discuss like the big picture of the strategies that I think are useful to iterate fast, even when you're working with long processes or slow processes. And some ideas such as how to reduce computations, how to do twice things that you could do only once, and the idea of how to reduce the size of the data and code, which is somehow captured by the idea of binary search, and also getting some feedback from the functions themselves to report the progress of how far you got into kind of solving the problem that the code is meant to solve. So that's quite a bit to cover. So let's get into it. As usual, this is the repository of this series, which again is the last meetup of the series. It has a dedicated folder called 03 All is Fail, and in that there is a document that highlights what I'm going to be trying to cover. I'm not hoping to cover everything, but let's see how far we get. So let's go to RStudio. And here I have a real package with which I'm working right now. And here I have a real script that I'm using to basically get a lot of web pages and download them into my computer. That's the simple story. So I'm gonna run this script in a way that is quite convenient, like clicking here on source or just pressing Shift, Control, and Enter. So that will run the whole thing. So the first time, I think you're gonna see that the process goes more or less fast, and then I'm gonna make it more vanilla to show you how painful it can be when you not take care of some things that can make processes like super slow. So right now, let me walk you through the code while this works. What is happening now is that the code completed all the way to the end of the script, and it's running some processes, but it's moving fairly fast. It's completing right now, 30%, and I'm moving forward. We'll see an error, I think, when we get close to 90% or something. Also, this code that is being run right now is the very last here. And it has gone really quickly through this first chunk of code. Although it is a very slow process, and I'm gonna make you experience the pain in a moment when this finishes. But I wanted to show you one strategy that I'm using to try make things a little faster for me. So the idea is to create a cache so that the data set that I'm creating here, if it already exists in a cache folder, then to reuse it from there. So if I run this line, this chunk of code over and over again, it runs very quickly, but only because it's reusing that cache. So let me show you what it looks like if I don't use the cache. So if I remove this for a moment and I rerun this, you will see that R is thinking, right? And it takes a long time. So that's one of the big picture considerations that does not relate specifically to debugging itself. But when you debug, you need to iterate over your problem over and over again, many times, sometimes until you find the issue. So if every time you need to discover a new flavor of the issue, you have to wait for a minute or 2 minutes, then you never really get to solve the problem that you want to solve. So finding ways to reuse computations is very important. Also, you notice that I rerun the whole thing by I mentioned it by pressing keyboard shortcut, Shift Control Enter, or by clicking here source. And that is the idea of making the problem as self-contained and portable as possible. By portable, I mean that sometimes you have paths in your script that are encoded to your own computer and have your name in it. And that's a very bad idea, because if you need to share your code with someone else, they will not be able to rerun the code, at least not without changing those hard-coded paths to use their own computer names. So for that, you could use packages such as the here package, which we mentioned in this same series a few chapters ago, a few meetups ago. So you can see that the process is still going, and it's really painful. So we can probably stop it here, hoping that my session won't crash. But now I am using the cache, so I'm gonna rerun it, just reusing the cache, and boom, there it is. Then this line is not all that important, and this one here is the one that is expressing the issue. But again, I can make the problem smaller and the process run faster by reducing the size of the data. So you may have noticed that the process completed all the way to almost the 99% of it. So there is a loop here going on, and there is these URLs that are being requested from web pages, and I'm using a trick. I'm avoiding to request things that I have already requested by using this argument overwrite. So I'm asking this function to not overwrite things that already exist in my computer. So if it detects that a file has been saved from an HTML file that has been already requested before, I'm saving that request. I'm not actually doing that request because I'm not overwriting it. So I could change that to overwrite equals true, and then this process would take actually literally probably days. So this argument is something that I had to bake, I had to write, but the effort was worthwhile, because once I figured out a way to reuse those or to avoid needless computations, then I saved a lot more of the time that I put into developing the feature. And still, we haven't talked about debugging, but I think that the big general strategies are more important to communicate here than the actual details of how you enter the debugger and stuff, because those details exist in documentation already. You can go to, for example, here in debug of RStudio and go to debugging help, and that will take you to a web page that explains how to use the debugger of RStudio, and that those tricks are published everywhere. But I find that the strategies that I'm trying to communicate here today are the ones harder to find and harder to discover. And by the way, also Jackson recorded a session on debugging, so we may also share the link to that video, which I couldn't find later. So one other thing that you may want to do is to reduce the size of the data, because even when this is trying to save as much computation as possible, it's still taking quite a while to go through that progress bar that goes all the way up to 99%. But if I know that my process goes all the way to 99%, I don't need to use that unique data set in its entirety. Maybe I just need to find the last 1% of the data that is the one that has the problem, right? So I could save computation in a very, very quick way by doing something like, okay, let's get unique and let's just get the tail of it, just the last, say, 1,000 rows. And let's see if that 1,000 rows already get me the problem that I'm trying to debug. So I'm going to try that and see if this goes a little faster. So now I'm reusing the cache to get that unique object from the cache. Then this line is not meaningful here. But then I'm reducing the size of that unique to just 1,000 rows. So now it has 1,000 rows. Before it had a lot more. Let me show you how many it had. Unique has 44,000 rows, more or less, right? So I reduce it to just 1,000 and then see if that process runs faster. Indeed, it does, right? So now it is in the, I have covered, 70% of that 1,000 rows data set, and the problem is there. So notice how much faster now my debugging session allows me to iterate over each time. So now I think I'm in a much better condition to try find the problem, because in a few seconds, maybe 2 seconds, I can already try something new. I see if I found the problem. So now I think is when we are at a point where we could start actually using debugging tools from the debugger, from RStudio, or from R in general to try find the problem. So the very first thing that I could do here is to try look at what's called the trace back. So basically the sequence of functions that have been called before the error happened. And I also pay a lot of attention to the error messages. I see here that it says cannot navigate to invalid URL. So it makes kind of sense. I'm trying to request a web page, and for that I have to somehow pass URLs, and that's exactly what I'm passing here. So if I show you a little bit what one URL looks like, this is what they look like. They look just like normal URLs, right? But at some point there is one URL that is corrupt apparently, and that's the reason of the bugs, right? So the first thing I could do then is to read that traceback. So there is a function called traceback that you can call, and it prints all this information here. It can be overwhelming, but I think one nice thing. I'm gonna rerun this to get another traceback that comes by default. Well, depending on how you have set up your RStudio, but you may have it set up in this way so that you can click here on show traceback and you get the same thing that I printed before, except that it has a little nicer format, some colors, and the colors help me because I can quickly see from all the code. I skim and look only at the code that has some line numbers in it. So this code comes from code that I've written. So RStudio knows where the functions are and in which files and in which lines the errors were exposed. So sometimes, this helps you identify something like this. It even makes sense, right? So I'm talking about, I sense that there is a URL that is corrupt. I had to navigate to those URLs, and if the URL is bad, maybe this specific line in the file write DOM HTML in line 30, that is the problem. So I could navigate there, and also I could try see the problem from a little before, because sometimes there is a sequence of calls that result in a problem, but the problem started earlier. But I think this is a really good beginning. I could go to that file, and remember that you can press Ctrl and the period, the point symbol, to pop up this go to file thing, and now start typing the name of the file that you want to explore. So write DOM HTML. I can click enter there, and the file has opened for me. So now I can go directly to line number 30 and confirm that exactly what I see here in line number 30 of that file is what's exposed here. So now I have a couple of options. If I want to see what this function is doing when it's run, I could I could do a few things. If you're using scripts, you can also click here on the side and set what's called a breakpoint. If you forget about this, you can always come to debug, and also I think there is a toggle breakpoint that allows you to set and unset breakpoints. When you're working with packages like I'm doing now, it's a little clunky. You need to load all the functions and blah blah blah. So I find it easier to use a coded approach where you type browser here. Browser is a function that will stop the execution of that function when it's called. Right. So that's one approach that you can take. So that, let's see if that works. This is one strategy that in many cases gets you there, but not always. So let's see what browser actually does for us. So again, I'm gonna press Shift Control Enter, and now because I ensure that the script runs fast, I can I have no worry. I run the whole thing and see what browser does for me.
Mauro?
Yes.
Just I want to interject a note real quick. That the RStudio and the traceback of being able to jump to a specific function definition in a file, that really only works if you're working with functions from scripts and you are frequently saving that script. If you do like I do, where sometimes you're like running a script interactively and you load a function, change it, load it again, change it, load it again, those definitions that R knows about can get wildly out of date, so save often.
Very, very cool point. Thanks, Alex. Going back here. So what happened while we were talking is the code ran, as we know, at the point where it exposes the bug, and then it stopped. So now I'm inside. You see how a browser is highlighted in yellow. So I'm no longer in my global environment. I'm inside the environment of the function that I'm trying to debug. And I have in here, this is the kind of the debugger console. See how it's not just the greater than symbol. It's a browser greater than. So that indicates I'm inside some weird environment. And here I have things that I can click on. Like for example, to continue, I click here and you will see.
Mauro, it's now 20 past.
Thanks very much. So I'm gonna run that once again because I kind of got lost there, and I think with continue I jumped out of the function, and that's not what I wanted to do. I wanted to kind of start working with the function here. Usually you press also next with you can use next from here or type N, and that will kind of move one line at a time. And here is, I landed on the line that I suspect that the problem is because the traceback showed me that. So one thing I could do is notice how now I have access to what the the environment inside the function. So there is this URL thing object, and that's the one I'm suspecting. So I want to see what that URL looks like. So here I would just type URL and see what I get. And fair enough, what I get is an empty string. So it looks like the function is trying to navigate. Somehow the data is corrupt and has an empty string where it should have an actual URL, and that's why it's going crazy. So one thing I could also do is use the function stir for structure to print while the function executes information that might be relevant for debugging, right? And I can leave the function like that for a moment and rerun it. Or even more usefully, you can use the function message, because the message function will print in red. In this particular case, let's use stir URL, and that's one way in which you could rerun now the function. Let's stop the browser. But we have learned something. We know now that there is a string. So we can do something like here. We can do fix me to leave a note. This is consensual. Many teams do use this flag, fix me, when when URL is empty string, I get an error, and then I can work from this. Even if I go now for lunch and I come back later, I know that I can search for fix me with Shift Control F globally, and I will find all the fix me's that I have in this particular code base, and I can go one by one and explore what problems they were. So what I wanted to show you now is what will happen now when I rerun this code. Now I put inside the function that I'm suspecting has the problem. I put a call to str, and here is the result of str, character empty. So this is one way to confirm that exactly where a URL should have been given. Instead, the function got an empty string. Okay, so let's go back and remove that. So the problem is now is clear. I need to somehow handle that problem. I could even say here something like if URL is the empty string, then stop bad URL, something like that. But right now, I'm not interested in handling the code so much as I am in finding the bad data. So to find the bad data, we can use an approach that is very general. You can use it for everything, to reduce anything and find just about anything. That is called binary search. So we have this data unique data set. And so what we can start doing is slicing the data to halves of it, and then see if the problem is in the first half or in the second half. So I'm gonna go and do that here. So here I ask the tail for that unique thing, but let's use instead of the tail, I could do I could slice the. I could use slice and something like, so this data set was 44,000, so I could say 43,000 from the row number 43,000 to the row number or to the last row, so which is last is n rows of unique. Right. Well, in this case, because I have, I'm using the already subset of unique, but now let's rerun that. So now the last row is 44,000. So that one there. So this will slice the data to just, the last few, rows, right? And I can run this again and see if the problem persists or not. Oh, here this is another bug. Actually, it's not the one that I'm interested in solving here, but it's this one here. Needs the session here, right? And now, so if the problem persists, so let me load this. So now let's rerun this. So in this case, the problem did not appear because it looks like the problem is in a subset of data that I have excluded. So basically, let's do that more simply somewhere else. So if you have empty cars, you can slice from row. How many rows is it? Let's first find out. So that is 32 rows. So let's do. First, let's slice it from 1 to half of it, so 1 to 15, and then we use this data set to see if the problem is there. If it is not there, then we can explore rows 16 to 32, and then we see if the problem is there. Well, it should be there, right? So now we can break this in half, so we can go from half of 16 to 32. So let's say here we go from 20 to 32 is that half. If it is, then you have effectively narrowed down the problem every time more until you will end up very quickly actually to just a few rows that you can just inspect by eye. So in this case, the unique data set, let's see, this is not the one that I want to show you. Well, in this case, the point is that the unique data set does have one row that contains an empty string where it should have a URL, and with a binary search you could find it there. So probably it's time to stop here. Let's see what comments or questions we have. I know here we have had conversation with some people in the audience about these ideas, so it would be interesting to see what you think. Let me then do a recap while you think if there's anything that you'd like to comment on here. Let's go back to. Okay, so if you're interested in the cache function, that usePin function that I showed, here's the code. It's just like 3 lines, like really simple, and I'm planning to show the pins package again recently, and I say again because we have covered the pins package that creates cache and handles cache in a meetup before, but pins now has a new interface, so I would like to kind of show the new interface and this personal function usePin that uses a pin if it exists, and if it doesn't, then it creates it. So that I will dedicate probably a hangout to that or something like that. So let's go back to my notes to see what things I covered, what things I couldn't cover. So we discussed traceback to try locate errors. We talked about the function browser. One function I didn't mention, I'm gonna show it like quickly. It is fairly advanced though, but I think it's pretty cool. Unique, let's do the tail here. As we did tail the last 1,000 rows. So this goes back, brings this script back to what it was before. So let me run this just to confirm that I'm good. And I'm going to show you one function that is pretty useful, which is, so once you find an error, especially if the error is one that appears in one iteration of within many, you may set so when R detects a problem, an error, what happens next can be configured. So there is an option in R called options error. And here you can do whatever you want. There is a bunch of things that you can pass to this argument. In this case, we can pass recover, and so that kind of sets the handling of errors in such a way that when the error occurs, you will be dropped in a debugger environment specifically where the problem was found. So let's go here to the script. I'm going to rerun the script all at once. And now with this new kind of error handling, let's see what happens. Okay, well, what happens here is that I'm now presented with a traceback and with a bunch of options like 1, 2, 3, 4, blah, 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 of where I want a browser to be inserted. So before I inserted the browser manually with options equals recover is the function, I'm asked to choose after the fact which is the environment of the function I want to enter. So here I could say something like this one, number 6, for example. Type number 6 and be dropped exactly where we were dropped before, without having to type ourselves the function browser. Okay, once more, back to your faces. If there's questions or comments, go ahead. In the meantime, I'm gonna put back again my notes. So we talked about.
I was just saying I have to go. So thank you, Mauro.
Thank you very much. I'm gonna quickly close, but not before walking through this. So now we talked about traceback. We talked about browser. We talked about recover. We talked about structure and message. Debug once is something similar to, basically allows you to debug. It's similar to introducing a browser statement inside a function without actually having to type it. And the once part comes from, it's only one time that it happens. And then, the second time that you call that function, it will behave as you expect. Pretty much we covered everything, and we talked more importantly about general strategies like, okay, try to make your problem self-contained, try to iterate as fast as possible by reducing computation and reducing the size of the data or code that you have to go through, and get feedback. In here is like the idea of, for example, trying to implement a progress bar to know how far you're getting into solving your problem. So that's about it. Thanks very much for joining. Any departing comment or question? We're good. All right. See you all next week with someone else. Hopefully, I don't want to announce it yet because it's still to be confirmed. But there's going to be a new series next week, and most likely, I'm not going to be the one leading it. So it's going to be something refreshing for everyone. Thank you. See you soon.
Thank you.
Ciao, ciao.